Well, I didn't expect to really make a video on the repair of these two K7000s. I've got several videos already on vertical collapse, what to look at, the common issues, things like that, but both of these ended up being a non-standard repair for vertical collapse. So I thought it'd be a good idea to go ahead and go over what I found and what the causes were. Basically, these are owned by a particular individual who tried to repair them, couldn't get them repaired, sent them to another individual. So individual A owns them. He couldn't fix them. Individual B took a look at them and he couldn't fix them. And so they reached out to me and said, hey, would you be willing to try and take a look and see if you can figure out where we went wrong? And I said, sure. So they sent them to me and I only ended up getting one neck board. This neck board actually came with this chassis, which is the first one I worked on. And I said, hey, I only received one neck board. They go, oh yeah, it must be here around here somewhere. So I'll ship them back to them like this and they can find the other neck board, hook it up and be fine. But these are now fixed, but I want to go over to reiterate, if this is the first one of these you're watching, the common issues you have to look at when there's total collapse. So this one had total complete vertical collapse. This one originally had total complete vertical collapse, but the owner of this did a cap kit to try and fix it, and then it became partial collapse. So I've got both these fixed, but I want to go over this one first and talk about the normal issues you're facing when you have issues of collapse and what you want to look at. Now this actually ended up being quite entailed. I got it and looked over everything and I noticed that the horizontal hold pot was broken and the vertical position pot actually was just spinning the complete 360. So the V position pot was bad and H hold pot was broken. So I had to change those first. And so somebody had already, in the attempt to try and fix the collapse, they had already removed and socketed IC1 and IC2, but they tested okay. And it was missing the fuse. Both of these were missing the fuse. I thought, okay, that's odd too. So I checked all the power components that I normally do and everything checked okay, put a fuse in and powered it up and it worked, but I had total complete collapse. So I did a full inspection on everything before I tried to turn it on, and I only noticed that these two issues on these two pots were the only real problem. So I didn't notice the problem originally because it's not something you normally would expect to be faulty or look at, so I missed it the first time around, but I found it when I went through to find the issue. But okay, you have a K7000 that's in full total collapse. Well, the first thing you want to make sure that the flyback isn't arcing. When the flyback is cracked and arcing to the frame, it almost always takes out R91, R92, D13, or D14. So the flyback itself will output 26 volts DC. It goes through two resistors, R91, R92, and it goes through two diodes, D13 and D14, and then it ends up over here at these two blue wires that go down in here. These two here are for your vertical. They go over here off of the IC. Then there's these two blue wires here. One runs down to one leg of R80, and R80 is the resistor that determines your vertical size. If you haven't, like, for instance, when I got this one fixed, I had, in the process of trying to fix this, the owner of this put in a replacement R80, but they put in an R80 that's supposed to be on a 19 inch. This is 25 inch. And they put in a 5.9 ohm resistor in R80, but that's for a 19 inch. So when you try to power this up, you can't get full vertical size because you have like an inch and a half on top, inch and a half on bottom. It's the highest it goes because they have a 5.9 ohm resistor in here for a 19 inch. So I took that out and I put in a 3.2 ohm resistor setup. I don't have an actual 3.2 ohm resistor, so I put a couple of resistors here in series. I think it's a 3.2 and a 1.2. I somehow ended up at 3.2 ohms. So I put that in there. That's what's supposed to be in there for a 25 inch. But one of these wires off of D13, D14, or 91, 92 off the 26 volt reference from the flyback, it runs here to R80 for your vertical size circuit. Other one runs over here to your vertical IC, IC3. So on this one, if we zoom in here, I'm going to talk about what you're expecting to look at. So if you have total complete collapse, the first thing I recommend doing is just taking the chassis out of the frame, leave it connected and hooked up, but just kind of take it out of the frame and turn it over, make sure nothing's touching or going to short out when you turn it on, and then turn it on, and you're going to want to check for your 26 volt reference from your flyback. Again, it comes out of this pin here, and it runs through this diode. I think it's D14. I think it's D14. No, that's 13. 13 is here, and 14 is here, and you have R90. I can never remember. Okay, and this right here is R92. that runs across here, and R91 is right here. So you can see your 26 volt reference out of here, and it runs through this diode to this point, across R91, and then to these 2 points here. This is their 2 blue wires, where one runs over to here and one runs up to here. So 26 volt reference, if you have total collapse, you can just eliminate, don't even bother trying to read all those through D13, D14, 91, 92. Just go straight over to here, because that blue wire ends up right here. And then it runs to pin 8. So you're looking here, there's only 7 pins here. 1, 2, 3, 4, 5, 6, 7. But the LA7831 vertical IC, this particular one right there, there's different types, but this one is 7831. Pins 1, 2, and 10 aren't used, they're actually cut off. So it turns out to be, this is pin 3, 4, 5, 6, 7, 8, 9. 3 is the ground, and then of course pin 8 here, I say of course, but this is your blue wire from your 26 volt reference. So you should have 26 volts on this pin. You should also have 26 volts on pin 8 here of the vertical IC. And then it runs through this diode. It's rather precariously installed here. This was done by the owner. I didn't do that. I just left it here because it works. Cleaned it up a bit, left it like that because it'll work, you know. And I didn't want to put forth the effort of putting it back through the top. It's a bit of a nightmare trying to do that with the heatsink. But you want 26 volts on this pin. If you have that voltage there, all this other circuitry is fine. But then it runs through this diode and then back across this trace here to pin 5, 3, 4, 5. So you should have 26 volts on pin 8 and pin 5. So if you have total collapse, take the chassis out, flip it over, and make sure you have 26 volts on pin 8 and pin 5. If you do, all of your chassis circuitry is fine. Should be fine. Caveat, asterisk, whatever you want to say, footnote. All of your circuitry should be fine. If you still have complete collapse at that point, you want to make sure your vertical size pot and your vertical position pots aren't broken, because the circuit won't run through this one here and R80 and all that. That circuit will be open if you have either one of these 2 pots broken. You also have to worry about this transistor here, which I believe is Q9. This transistor here could be shorted, which could cause collapse. So you want to make sure that transistor is not faulty. Okay, let me stop here. That is about the normal culprits. You can either have a faulty IC. If you have your 26 volt reference from the flyback and your 26 volt reference coming off the power for pin 5, if 5 and 8 both have 26 volts, it could be just a simple issue of a faulty vertical IC. And the easiest way to test that would be to go to ground and make sure none of the other pins check to ground. If you go to ground and you go 4, 5, 6, 7, 8, 9 to ground and none of those read to ground, the IC is likely fine. If any other pins read to ground that shouldn't, the IC is your problem. So those are the common issues to check. Now, what else are the uncommon issues? Well, an open R80 would cause collapse, so you want to make sure R80 is not open. That's the first thing to check when you have exhausted everything else. You could have a faulty IC2 because your vertical deflection circuitry runs through IC2, which I'll talk about on the other chassis, foreshadowing. And then you have other passive components like various polycaps and resistors and things like that, but those almost always never fail. And that's part of the reason why I'm doing this video, because the fault with this one is a fault I have never seen before. I say that because I don't recall it. I may have seen it in the past, but I have never seen this particular fault cause total, complete vertical collapse ever until this very moment. So with all that being said, the cause of this total, complete collapse was this polycap, C53. This cap looks like somebody either took a pair of cutters and just cut a chunk off the top, or it exploded, but it's completely, totally shorted. C53, which is this cap right here. C53 is this guy. You can see here it says C53, boom. So this cap was completely, totally, utterly shorted, which if you want to see here, I will show you. Actually, let's do it with the component tester, just so you can see here. So we'll put the legs here across pins 1 and 2 of the tester. We'll close it up, and it should read a capacitor, but it reads resistor, 0.1 ohms. So, yeah, I don't know what happened to this, but this was dead shorted and the direct cause of our total complete vertical collapse. So I wanted to kind of go over that, talk about some of the things to look at. Make sure you have voltage on pins 5 and 8. If you do, make sure that that means all this is good. If you don't, check all that. What I mentioned over here, D13, D14, R91, R92. Make sure your wires here that reach over here are good. If you still have collapse after that, you check to make sure your IC isn't shorted. If that's okay, then you have to suspect IC2 might be faulty. Or if you change that out, like this person changed out IC2, it didn't fix the problem. That's because in this case it was this capacitor. So if you all else fails, get yourself the schematic and just start going through component by component, and that's pretty much how I ended up finding this. Because I didn't notice this, it sits underneath this ribbon cable. Ribbon cable was like that and I didn't even see it. So I had to go through component by component, and I'm looking at the schematic, which I'll show you right now where that is on the schematic and what it ties to in the circuit. So after looking at that, I was like, okay, so you go component by component. When I got to C53, okay, I'll check that. Where's that at? Oh, there it is. Oh, well, look at that. And sure enough, it was dead shorted. So, that's kind of the process you have to do when you come across things like this, is when it's not anything in the norm, you have to start looking at the abnormal and grab the schematic and go component by component and take stuff out of circuit and all that. But yeah, you got the components over here, your possible IC3, your possible IC2, your possible open R80, other passive components, and things like that. And one more component you want to verify is D25, which I'll get to on the other one and you'll understand. So that was the cause of this one, a shorted C53, total vertical collapse. Replace C53, back to fully working. After some adjustments and everything, it looked great. So that was what was wrong with this one. Now this one took me quite a while to figure this one out. This was a bit of a nightmare. This one also had a broken vertical position pot. I had to fix that. But this one had total complete collapse until the owner recapped it. After he recapped it, then he had partial collapse. And I'll show you after. Instead of just posting pictures, I'm going to come back and do a live video with this running, and I'll show you what it looked like. But basically this one, all of the same things I just talked about on that one apply to this one. But in this case, we had a bad IC2 and we had a bad D25, this one up here. But what caused that? Well, the person that owned this and did the rework on it, they did a little butchery. And they tried to replace Q8 here, Q9. Yeah, they tried to replace Q9. When they did that, they actually installed it backwards, and I think that's what caused some of this damage I'll talk about shortly. But they also completely destroyed the whole area here, so I had to do a lot of rework. What I found was there was a short between this. So this is the transistor here. There's 3 legs here of that Q9 transistor. And this goes to the potentiometer here, the vertical position pot. There was a giant bridge across these 2 points right there. And I think with this bridge across these 2 points, it actually ended up damaging IC2. And you can see that this had to be reworked also. And it also shorted D20, no, I'm sorry, not short, open. D25, so the problem with this, it had full collapse, they capped it, and then it had partial collapse because when they messed up this rework and caused that bridge, it took out IC2 and it opened up D25. Now you can see here, they, instead of taking the IC3 out off of the frame, they took the entire heatsink out and they kind of burned the board. I think they used a air rework station, easy for me to say, and they actually burned the board and burned a little bit of the trace, and they burned this over here, and this is the best I could get it to solder back in. It was pretty much a nightmare. But anyway, so that was the cascade failure on this. I found this kind of in a weird way, is I didn't know that IC2, so you can see somebody had taken the old one out, put a socket in there and replaced it. And how I found this was I spent hours going over every component, every passive component, and I couldn't figure out the problem. What was happening is I was getting my 26 volt reference at pin 8, but I was not getting my 26 volt reference at pin 5. Now, if you recall, what I said was the voltage comes from the flyback, it goes through pin 8, it goes through this diode, and then back around to pin 5. I was getting no voltage at pin 5, 0.3 volts DC. So I checked the diode, and it was wide open. This diode is wide open. I'm not even sure if this is the right diode that's supposed to be in there, because I don't remember there being like a zener in there, or really that's what that looks like. But that's what was in there. I think maybe somebody replaced it with the wrong kind, and because it was the wrong rating, it opened up. But regardless, this is what was in D25 position, and it's completely, totally open. That's the cause of no voltage at pin 5. I put this 1N4007 in there, and again, I put it on the bottom of the board because it's hard to put it in with the screw here, and it's like, you know, that's why it's the amateur channel. That's why the other guy put it on the bottom. But after putting this in there, I got my voltage back at pin 5. But I still had, the issue was still there. I still had partial collapse. So I went through and spent hours going through every passive component, everything on the entire, I printed out the diagram and the schematic, and I went through and checked every single component. I could find nothing wrong. I changed the IC again. It didn't fix the problem because I had all my correct voltages. It wasn't shorted. The original one, I changed this out. I could find nothing wrong. So at that point, I kind of got frustrated. Knowing that IC2 is part of our deflection circuit, I took the IC2 out of this one, and because the other chassis also has IC2 in a socket, I thought, okay, well, let's first take, if there's something on this, here's how you should do this. If there's something on this chassis that damaged that IC2, you don't want to put a known good component in a possible faulty part, because then you can actually, now you'll end up with two bad IC2s. If something took this one out, now you just took this one out. So whenever you do this, you want to take the suspected faulty component and put it in the working board. That way, if there's something wrong with the component, you won't damage your, now you'll end up with two bad chassis. So that's how you want to do that. So I took this one out of here and put it in this one, knowing that this one works perfectly fine. And guess what? I had partial collapse on this chassis. I took the IC2 back out, put it back in here, I put the original one back in here, and on this one, I got full deflection again. So I ended up verifying that the IC2 was faulty. And here it is. So that one had a shorted C53, and this one had a bad IC2 and an open D25. Two things that you really wouldn't suspect with collapse. Very unnormal, abnormal, Abby someone. Very abnormal for the IC2 to go out, and I don't think I've ever had a faulty D25. But in this case, D25 was open. I think it was the wrong diode that was supposed to be in there. Somebody probably tried to change it in the past and put the wrong one in there, and the IC2 was bad. So I'm not going to show this one because this one works fine. This one just had the bad C53. But with all that troubleshooting, I was so elated to finally get this one fixed because this one was a real head scratcher. You know, it was a combination of IC2 and an open D25. So after replacing D25 and getting my voltage back at pin 3 on the IC, it still had partial collapse. I'm like, what in the world? I started thinking maybe there was still something wrong down here with the bad rework. Maybe Q9 was faulty after being put in backwards. I had to take that back out again. I mean, I did everything you could possibly imagine and think of. And it wasn't until I took this IC2 out, put it in the working board, and found that it had partial collapse on that one, I realized, okay, IC2 is bad. So I grabbed a spare, put it in. Guess what? This works now. This works perfectly fine now. So what I'm going to do is, just for demonstration purposes, in case you ever actually come across this and you can look and see, I had this exact problem that you're going to see shortly on another one of these in the past, and it was caused because C50 had a broken pad. Someone sent me one of these that had the exact same problem you're about to see, and this leg on C50 was actually broken. They had lifted the trace and it broke the pad, and there was no connection down here to this point, which is the ribbon cable here. which runs over to here, which runs down to the vertical position pot. So basically our vertical position pot was out of the circuit. So again, if you have a broken vertical position pot or a broken vertical size pot, you'll have complete collapse. So you want to check those too as part of your normal procedure. But the vertical position pot runs through this ribbon cable up through C50, and then it had a broken pad there. And that caused the exact problem you're about to see. So it can be any number of different things. You have to check, go through with a fine-tooth comb and look at everything. But in this case, it was the IC2 and that diode, D25. So let me get this on a tube, and I'll show you that it's fully working. And then I will install this faulty one so you can see what the discrepancy looks like if you ever come across this in the future. And then I'll put this one back in, and you'll see it come back to life, and we'll call it good. So just a quick overview of this stuff. I wanted to put the information out there because this was a real head scratcher. Let me get this on a tube. We can demonstrate this, and then we'll be done. Okay, so we have it here on a U5000 tube. I don't have the right kind of frame in here, so it's kind of sitting here on a little magazine, kind of precarious, but it's all hooked up, ready to go. I have MK2 here that I always use for testing for valid video signal and everything. So then I have our bad IC2 here with the X. We're going to slave in here shortly. So let's turn this on, and you can see that it's working now. And after changing out IC2 and the D25, we have full deflection. So here we go, 1, 2, 3. Okay, comes on. And I've had the tube off for a while, so it's going to take a little bit. Oh, maybe not, but there you go. Full deflection. Works great, lasts a long time. Okay, now what we need to do is I'm going to shut this off. We're going to remove this IC2 just so you can see an example of what this issue looks like if you have this for yourself in the future. And why would I not drop it? And I'm going to apologize here for the shaky camera work, but it's hard to do this with only one hand, and it's the amateur channel. Okay, so there's our working one. We'll grab the one here with the X on it that doesn't work, and we will install it. And by install it, I mean drop it. I'm trying to look through the camera and this at the same time to make sure I get it in shot. Okay, it's installed. There's our working one. And here we go. 1, 2, 3. Okay, comes on. And here's what you get. And not only is it collapsed, but vertical hold doesn't work. So if I can adjust vertical hold to my heart's content, that does nothing. And if you actually follow the circuitry on the schematic, the vertical hold pot runs through IC2. That's why this makes sense. So you can see here, if you ever have a problem that looks like this, constant rolling, can't adjust vertical hold does nothing, and partial collapse like this, you can suspect IC2 and or C50. I had the same problem with C50 being out of circuit because it runs through to the vertical hold pot in Q9. So, yep, that's what it looks like. Let's take this back out. If I can. And by back out, I mean fling it off into nowhere, into no man's land. And we'll put the working one back in. There we go. I'm going to seat it a little bit further back. Okay, and make sure we're not touching anything. Okay, turn it back on. And let's make sure our deflection is back, and it is. Voila. So, that's about it. Just wanted to talk about the vertical collapse issues on the 7000 again, and do a show and tell and a showcase of what a bad IC2 can do and what it looks like. So I'm going to take this and throw it in the garbage, and we are 2 for 2. The other one works just as fine as and looks as good as this one. So that's about it. I appreciate you very much for watching. Make sure you like, share, and subscribe. We got some GL bars there, interesting. Yeah, give it a thumbs up. Let me know what you think. Comment down below, and we'll see you next time.